We're continuing on in Unit 2 today by talking about compound inequalities. By definition, compound inequalities are two inequalities on one graph. They will either be graphed facing outward or facing inward. The first type that we're going to look at is outward graphs, and these typically contain the word or. So like what you see, x is less than or equal to a negative 2, or x is greater than 2. Now, as you can see by problem number 1, we have two specific inequalities we're going to have to solve. The first one is x minus 4 is less than a negative 7. The other inequality we have to solve is 2x is greater than or equal to 12. Now these will both be graphed on the same graph. One step solves each. We're going to add 4 on the first inequality, and we'll have x is less than a negative 3. The other inequality, we're going to divide by 2, leaving us with x is greater than or equal to a positive 6. Now for our graphs. The first one is going to be an open circle at a negative 3, and we're talking about numbers that are less than, so our arrow should point to the left. The other graph is going to be at a positive 6. The circle is going to be filled in because we're including 6 in our answer, and we're talking about numbers that are greater than that positive 6. Now for the interval notation, this is really important that we get this right. Since our first graph is pointing to the left, we are going to negative infinity. We started at a negative 3, and we didn't include the negative 3, so we have to put a parenthesis around it. That's how we would answer the first part of the graph. The second part starts at a positive 6, and we include it, so it's a bracket, and we are going to positive infinity. And that would be our answer to problem number 1. I'm going to skip down to problem number 3, just to kind of get some variety in here. Eventually I'll have you go back and do the other ones. But problem number 3, again, we have two inequalities we have to solve. The first one is 2x plus 9 is greater than 17. The other is 5x plus 10 is less than 10. We subtract 9 on the first one. We would have left 2x is greater than positive 8. Divide on both sides by 2. And x is greater than 4. The other inequality is solved almost the same way, but we're using different numbers. We'll subtract 10 first, canceling out our 10s. We'd be left with 5x is less than 0. Divide by 5. And x is anything less than 0. Now for the graphs, both of these graphs are going to be open circles. We'll have an open circle at a positive 4, and we're talking about numbers that are larger than 4. We have an open circle at 0, and we're talking about numbers that are less than 0. Now for our interval notation, what we're going to do is we're going to look at the graphs for both of these inequalities. The first one being everything that is less than 0. Since we're talking about less than 0, we are going to a negative infinity, and we start at 0, and it's going to be a parenthesis because we don't include 0. The other inequality, we start at 4, and it'll be a parenthesis because we're not talking about greater than or equal to 4, we're talking about greater than 4. And we are going to positive infinity. The second type of compound inequality we're going to be talking about and looking at is inward graphs. These contain the word and. So if you're looking at an inequality like what we see here, negative 2 is less than x and less than or equal to 1. So this number has to be anywhere between a negative 2 and a positive 1. Now, here's how we solve these. On problem number 6 on your note sheet, we have 2 is less than or equal to x plus 4, which is less than 9. So here's what we're going to do. I want you to write two inequalities. The first one being what you see on the left. 2 is less than or equal to x plus 4. The other inequality I want you to write is x plus 4 is less than 9. Now, what this is going to do is it's going to help us to solve for the two solutions we should have for x. So with the first inequality, we're going to subtract 4, and it'll be the same step to solve the second one. But we'll subtract 4, canceling out our 4's, and it leaves us with negative 2 is less than x. The next problem, we're going to subtract 4. The 4's cancel, leaving us with x is less than 9. So, if we were to look at this inequality, this is what it would look like. Negative 2 is less than or equal to x, which is less than, that should be 5, which is less than 5. Now, for our graph, this is what we're going to do. We're going to circle a positive 5, and we're going to put a filled-in circle at a negative 2. Now our graph is going to go in between those 2 points because we're talking about a number that's between a negative 2 and a positive 5. For our interval notation, since we're including negative 2, we put a bracket and then negative 2, and then we're going to have a positive 5 and a parenthesis because we don't include the positive 5. So our answer is going to look like this after we've shown all of our work and after we've solved the inequality. We'll have negative 2 is less than or equal to x, which is less than 5. Our graph is going to look just like it looks on the slide here, and our interval notation will be negative 2, 5. Now, what I want you to do is I want you to try your best on the rest of the example problems on your note sheet. If you have any questions at any point in time, you can feel free to email me or put a star beside the problem that you're struggling with, and we'll address it when we come into class tomorrow.